Here's a question in probability. Two dice are thrown at the same time. Find the probability of getting at least one 5 and B, a total score divisible by 5. Now, when looking at this question, it may sound as if it is very easy to give an answer to the question. But here is the simple truth. You cannot solve this question without constructing what we call an outcome table. So in this video, I'm going to show you how to construct outcome tables and then use it to get the solution to the question A and B. Well, the first thing I'll do is to use my rule. So pay attention to how I construct an outcome table because you'll be expected to construct one. And it's going to be something like this. I'm going to explain the reason why I'm doing this. So just pay attention. I'm supposed to have a dice at 6 side. So I'm going to have 6 rows and 6 columns. And it says 1, 2, 3. And let this be my 4. And let this be my number 5. And let this be my number 6. So that's it. So the column will be 6. 1, 2, 3, 4, 5, 6. So let's go. This is 1, 2, 3, 4, 5, 6. And then here will be 1, 2, 3, 4, 5, 6. So this is for the first dice. So you could call it dice 1. And this is for the second dice. So you can call it dice 2. So remember, 2 dice are thrown at the same time. If I throw 2 dice at the same time, what will be the result or outcome of throwing those 2 dice at the same time? Now, these are what I'm going to use to fill into the spaces I have here now. So it's very easy to fill into the space. Just what I'm going to do. I'm going to add 1 plus this 1. It's 2. 2 plus 1. 3. 3 plus 1. 4. 4 plus 1. It's 5. 5 plus this 1. It's 6. And 6 plus that's 1. It's 7. But it doesn't matter where you start from. But I decided to start from here because it is 1, 1. This is 1 plus 2. 3. 2 plus 2. 4, 3 plus 2, 5, 4 plus 2, 6, 5 plus 2, 7, and 6 plus 2, it's 8. And you go to 1 plus 3, it's 4, 2 plus 3, it's 5, 3 plus 3, 6, 4 plus 3, it's 7, 5 plus 3 is 8, 6 plus 3 is 9. Did you notice it's following a pattern? 1, 2, 3, 4, 5, 6, 7. Just complete it with a pattern. 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. It's the same thing if you decide to add both sides, you will get the value, but just to make it easier for us. So I have completed the outcome table. Now I can find the answer to my question. So what is the answer to the question? Number A. Find the probability of getting at least 1 5. Getting 1 5. So what do I need to do to get 1 5? See? Now, the phrase at least 1 5 means when you roll the dice, there are 2 dice. One of them will be 5, or both of them will be 5. That's the meaning of at least 1 5. It can be 1 5 or 2 5. but at least one and above. And because they are just two dice, so it's gonna either be 1, 5, or 2, 5. Now, in this case, this is what you're going to do. You're going to have it here if it is 1, 5. And then here, if it's also another 5. So this is it. So these are the arrows indicating what we're going to count. So here, I could say, let this be P and let this arrow be Q. So a question, at least 1, 5. Now, P should be the outcome with 5 on die 1, dice 1. While Q should be the outcome with 5 on dice 2. So we're looking for the probability of obtaining P unit Q so this is going to be N divide N the entire set you have there. This is the probability of obtaining 5 on die 1, which is P. Let's count. 1, 2, 3, 4, 5, 6. So it's going to be 6 unit Q plus. Then obtaining 5, 1, 2, 3, 4. Now remember, we've counted this. We're not going to count it again. So 5. Divide the sum of this you have here now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6 times 6, 36. And so the answer to this question will be 11 over 36. So that's the probability of obtaining at least 1, 5. So it's not going to be 12 over 20, 36. Don't get it confused. Remember, it could be 1 or it could be 2. Now let's go to the B part of the question. A total score divisible by 5. Now let's go back to our table. Let's circle the ones that can be divisible by 5. We'll have this, we'll have this, we'll have this, and we have this. Please remember, this is not part of it because this is the dice. So I am supposed to draw a second line here to separate it so that it's not part of what we're doing. So this is the double line showing that this is the dice and double line showing that this is the dice. So we don't count it among what we're doing on the outcome table. And then we'll go circle the 10, the 10, and the 10. So let's count. 1, 2, 3, 4, 5, 6, 7. So the probability is 7 divided by 36. That's the answer to the question. Now here's another question. Still in probability where you have the number of apples in a bag and the number of lines you have in a bag. Now let's check it out. You have 10 good lines and 6 bad lines in a bag, 8 good apples and 6 bad apples. Now if 2 fruits are picked at random, one at a time without replacement, find the probability that both are good lines, both are bad fruits, and one is a good apple and the other a bad line. Here's an interesting question. Take note of this phrase. without replacement. Now, sometimes in probability question, you may be given a question where you are told with replacement. Now, with replacement means that the number of possible outcome will not change. But here, the number of possible outcome is going to change. Probability has a formula. The formula is number of required outcome divide number of possible outcome. So what do we do in this question? Now I'm going to go straight inside of the question without giving unnecessary details. The probability that they are good lines. Yeah, both are good lines. You see, if I do the first speaking, there are 10 good lines. It's going to be 10 required outcome divide possible outcome. So the question is, how many fruits do we have in the bag? Now recall this is 16 lines and this is 14 apples. So 16 plus 14, that gives you, or if you want to add it, 10 plus 8 is 18, 6 plus 6 is 12. That should give you 30. So this is 30. So in the first picking, this is the first picking. First picking, you're going to pick 10 out of 30 fruits because the 10 are good lines. Now we're going to the second picking. Now in probability, both is the same thing as multiplication. So 10 multiply. Second picking is going to be 9 out of 29. Why is it 9? Because you've picked one and it was not replaced. So if you pick one out of 10 good lines, it will be left with 9. And then the number of apples in a bag will be left with 29. So this is what you're having. 9 times 10 is 90, and 30 times 29 should give what you're looking for. But that would be too difficult to simplify. So why don't we just simplify it here? 10 and 0 cancel 0. 3 here is 1, 3 here 3. You know, we're trying to solve with a calculator. And then the answer I'm going to get is going to be 3 divided 29. So that's the solution to the problem. So let's go to B part of the question. Now, probability that both are bad fruits. Bad fruits. So we're going to have B, F, bad fruits. What does that mean? Which means the lime is bad and the apple is also bad. So the first thing we're going to do is to get the total number of bad fruits. Total number of bad fruits is 6 plus 6, which is 12. Yeah. 6 bad lime, 6 bad apple. Okay. So let's go to the probability that both fruits are bad. Now, first pick is going to be 12 out of 30. The 30 fruit there. Now, both in probability means multiplication. I've picked one from the 12, so I'll be left with 11 in the second picking. So this is second pick, and there will be 29 fruit left. Now I can simplify this before I multiply. 3 can go here to be 4. No, 6 can go here to be 2. Yeah, 6 can divide 12 to be 2. 6 can divide this to be 5. So this is easier now. So 2 times 11 is 22. 5 times 29. 5 times 9 is 45. So 5, and take the 4 to the other side. 2 times 5 is 10 plus 4. And gives you 1/4 of 5. So this is the answer to the question. So remember, first pick and second pick. That's what I did in solving the A part of the question. Okay, let me write the second pick here. So let's go to the C part of the question. One is a good apple and the other a bad lime. Very interesting questions, right? Now, in this question C, we have to be very careful The question did not tell us the order in which it was picked. It didn't tell us that the first one we pick must be a good apple and then the second picking must be a bad lime. It just simply says find the probability that one, without any particular order, it's a good apple and the other a bad lime. So in this case, we're going to solve for what we call either the first pick is a good apple and the second pick is a bad lime, or the first pick is a bad lime and the second pick is a good apple. That's what we're going to solve. So let's solve for probability that first fruit is a good apple and the second pick is a bad lime. Or probability that the first pick is a bad lime and the second pick is a good apple. So take note, the A stand for good apple and the L stand for bad lime. Let me just put this on top, bad lime, good apple. So here, in this probability, that it's a good apple is 8 over 30. That is a bad lime, it's 6 over 29. Now remember, it's always decreasing because the number of possible outcomes because it is without replacement. But since they are of different fruits this time, the value will still remain the full fruit you have for each of them, or its addition in probability. Now, bad lime, this time around is going to be 6 over 30. Multiply good apple is going to be 8, bottom reduced by. So that's what you're having. So if you solve this, what are you going to get? Well, let's see. This will be 5. And so this is 8. 5 times 29 is 145. We've solved this before. Plus 6 here. 6 here is 5. And that gives you 8 over 145. Yeah. So this is 8 plus 8 divide 145, which is 16 divide 145. So that's the solution to the question. Thank you for watching. Please remember to subscribe to my YouTube channel, like my video, share it. I want to get your feedback. Use the comment section. If there's a question you want me to solve, please put it there. And if there's any question, use the comment section. See you in the next video.